So I handed back the exams, so if someone's not here today, future classes, I'll be bringing them this whole week, or probably next week as well, just to make sure if you get those back. I still have the multiple choice, and I'll probably bring those with me Thursday. If you want those, you can get those on Thursday. I'll post what the answer key is so you can kind of figure out which ones you got wrong in multiple choice. And then kind of what I handed back is I graded them by hand so you can kind of see why points were taken off. I usually throw in a couple words there. I was going through them quick. So if you can't read anything that I wrote and you're curious about why, feel free to kind of ask me exactly what the issue was. I also have an answer key that I'll get up there for the short answer that kind of has maybe even more than necessarily what I was expecting, but kind of you can kind of see what a real detailed worked out answer would have been. Overall, it was kind of split. Quite a few people did pretty well. Some people didn't do quite so well. You notice a high correlation with the people that are generally here in class and then performance. So I would strongly suggest continue to try to attend class as much as possible here the second half of the semester, kind of leading us into that final. The average, I think, was I curved. I made some of the the short answer. There were a bulk of points, and so if you didn't do too well on one of those, maybe you misunderstood the question. There's multiple parts, and so there's a lot of points. So I actually dropped whatever your lowest, kind of whatever short answer question you missed the most points on. I actually just kind of gave you those points back. And the average ended up being right around, I think I did a 4-point curve just to get my average right around 75. So overall, average was right around a 75, which is where I like to see it. After that was done, like I said, kind of there's people on both sides. So it's 20% of the overall grade. So if we look up on Canvas right now, oops, not that one. I moved things around so that if you're looking at these assignments, you've got all your online quizzes, your 2 homeworks, and then the exam grade, and kind of weighted according to the syllabus. So obviously we still have the project, the final, some more homework assignments that we'll get in the online quizzes I'll get added in there, but it should give you a good idea of where you're at in the class right now. And if you didn't do too well in the exam, you still have the final as well as the project, which is worth or weighted more than both of, each exam's 20%, the project's 25. And so still a lot of time to make up, or a lot of points to make up there. I'm also I probably a little bit more than half to 2/3 have got the project data out there. So that is my goal this week, is to get all of them kind of sent. So a lot of you have probably seen some emails from me, and if you haven't, you should be getting one this week that has some data. I think that you can at least kind of get going on those projects on the data and analysis portion. Okay. Thursday, I'll bring in something to kind of walk through, kind of revisit Excel, how we run these regressions, how we interpret some of the coefficients. So we'll get a little, every week I'll probably start doing a little bit more data work the second half of the semester. So you'll get kind of an idea about how you should be approaching that data analysis section. Yeah.
So you dropped the lowest short answer question and added a 4-point curve.
Yep. Okay. Yep. And so for everyone, that's going to be different what question it was. It wasn't like I just one question for the whole class. It was each person. If there was a misunderstanding where you missed a lot of points, I didn't want to have that over penalize you. So kind of dropping that lowest gives me probably a more accurate idea of how you were actually understanding the material across all 5 questions. Yep. Any other questions before we kind of jump into material today? Okay, so that grade should be up there on Canvas. You should see that exam 1 grade. Other than that, we'll hop into things here today. So we'll revisit some stuff we've already talked about in relation to the labor market. But we're really going to kind of dive in. So the first half of this course, we're a lot more thinking about like the team's decisions, league decisions, cities, kind of, their interactions with teams. We're going to focus a little bit more the second half on actual athlete, like the players, the athletes. We'll even do some kind of college athlete analysis and go over some topics that are related to that. So kind of our basics, right? So if we think about who's demanding labor, we've already kind of went over this, right? It's the actual teams or the leagues are demanding labor, right? Who's supplying the labor? These are going to be our players, right? So we've kind of already built this up prior to spring break. So we think about what is labor for demand actually based on. So this is what we didn't really dive too deep into. But if you think about, I'm probably going to jump the gun a little bit here, but I think this is all right. So if we think about why the team is going to demand labor. So we've got our quantity of labor and our wages, right? And we think about, we've got this demand for labor curve. Okay? So typically, what does the demand curve reflect to us? We're thinking about like a general product. Demand reflects the consumer's willingness to pay, which I usually kind of also put in here, right? They'll pay up to whatever their additional benefit is, right? So the demand curve usually reflects our marginal benefit. But what's the marginal benefit of a player? Right? When I bring a player in, if I'm purely thinking about kind of the economic decisions of this team, right? What's the value of that player to the team? Right? Well, it's going to be, so we think about the demand curve for labor, it's really going to come from, well, how many additional wins is this player bringing in? So usually we think about this as the marginal product of labor, but for us, kind of the product is wins. Right? And then what's the value of each win? Well, that would be just be the additional revenue that's generated from each win. Right? So you've got the number of additional wins that player would add to the team, multiplied by the value of each one of those wins. That would give you kind of the total value that players bring to the team. So we'll usually kind of reference this as the value of the marginal product of labor, or if we wanted to here, we could call this the value of the marginal wins that are coming from labor, right? Because our product is, this is a W. Our product is wins. Right? Let me see here. There we go. So that's kind of where that demand for labor is coming from, is it's really the value that that player is bringing to the team. Okay? So we can think about there's going to be certain things that influence the productivity of the player. There's also going to be things that influence how much revenue is generated from each additional win. Now, if you wanted to, you could complicate this. So you might say, well, look, teams don't just care about, right? Wins aren't the only thing that brings in additional revenue. Maybe we could throw in some additional factors with, fan interest or something that isn't associated with wins. And it would complicate this a little bit, but for the sake of what we're doing, right? I mean, those are probably going to be somewhat negligible to what the team is really going to care about, which is the additional revenue that players bring in. Right? So you could complicate this a little bit further, but for the sake of what we're going to do, we're going to just keep it at kind of what that revenue generated from the additional wins the players bring in. Okay. Any questions on that idea? Okay. So if we think about how many wins that player is going to add and the additional revenue that's generated from those wins, which league might we expect to see the lowest salaries? Well, really, the marginal wins coming from the labor, I mean, this is going to be pretty similar across leagues, although you could argue in certain sports, right? Some, maybe basketball, there's only 5 players on the court at a time. Maybe they have more influence, so they can bring in a higher number of additional wins than, one of the technically like 22 plus players on a football field. We're thinking about offense and defense. And so maybe some sports, the additional wins that a player would bring in, that might kind of shift the demand a little bit. So, in a sport like the NBA where there's fewer players contributing or fewer players, right, being a part of the equation for wins, maybe we see the demand curve for labor be a little bit higher there, right? Because the marginal wins that's coming from your labor is going to be a little bit higher. Well, that demand curve is going to shift higher. And so if you have the same kind of supply, that's just going to push the wages up. We can also think about what league generates the highest amount of revenue. And if we're looking at kind of per win, we can kind of think about the NFL probably has the highest if we just look at the revenue data. I don't remember off the top of my head how it ranks after that. I just know that if we look at the data, NFL is typically on top when we look at revenue per game, right, or per win. So we can think about both of these factors, right? If we're kind of comparing across leagues, both of them might cause our demand curve to shift, right? So maybe the NFL has a slightly higher demand curve for labor because it's bringing in more additional revenue per win, but it's also going to have a slightly lower demand curve because maybe each individual player isn't as I won't say valuable, but isn't bringing in as many additional wins, right, as some of the other leagues. So it's kind of hard, right? We've got 2 factors competing with each other, and both of them are going to shift this demand curve. Okay. Whoops. So, if I was guessing here, I probably would guess NFL just because that marginal revenue per win is high. But there's really no right or wrong answer because, maybe it's the NBA because we see the additional number of wins a player can bring to a team is a little bit higher in sports like the NBA, where we don't have as many players contributing to the game. Questions on any of that? Comments? Just kind of building some things up here. So, if we just looked at some of the data real quick, just to get an idea, the NFL, so if we looked at the average maximum salary, and I think I kind of did this prior. So I say 7 seasons starting with the season prior to COVID, just because that screws up a lot of the data. So we want to kind of just take a look at that. And we see about an average about 22.2 million. Now, this is an average. So what do you think's probably going to end up being true? What's driving this number to be up so high?
The players who are paid like a lot.
Yeah, so if we look at the players so if we guessed in the NFL, what players would those be? Quarterbacks, right? So we might have positional salary differences. And so even though we're looking at an average that's relatively high, maybe if we exclude quarterback salaries, this is quite a bit lower, right? It's pulling that average up quite a bit. So, it's we want to take this with a grain of salt, right? Even though it is, I think when we look at the other ones, I think this might be the highest. We have to think about there's positional differences as well. So if we looked at, so if we looked at, that's the average maximum. The average single player is only making 3.6, right? So significantly lower. If we think that demand has risen over the last 7 seasons, what trend would we expect? We would expect, if there's growing interest in NFL football, that's going to push up the additional revenue that's coming per win. Demand curve would be higher. If we think this demand curve is going to be higher, you think about it. So I've got my supply of labor. Maybe this is where the wages were before. Demand for this sport increases, driving up that marginal revenue per win. So we'll kind of call this P2. We would also expect to see wages going up as well. So anything that is increasing in the product market, and our product market here is kind of the revenue that's coming from wins. Our product is wins, but then we have additional revenue coming from each of those wins. That's going to also drive up the wages or the amount of money I'm going to pay for my inputs here being the players. Right? So this is true about, really any product, even if we're looking outside of sports, right, or outside of a labor market. So if we looked at the actual data, does that hold? Well, it looks like it was pretty stable and then kind of increases here, took a little bit of dip in 2017. But, if I'm looking at this, maybe demand for NFL has increased a bit, but based off of what their players' salaries are, looks like it's fairly stable, maybe a slight increase.
What's the difference between the average maximum salary and the average salary?
Yeah, so average maximum salary is going to be, if I'm looking at who the highest paid player is in the NFL, I think that's what I did is I just took the highest paid player over those 7 seasons and looked at what the average was. So if you look at that, I think that's also kind of steadily somewhat, increasing, not a real sharp increase, but something that would look kind of like this. So I then did that for, Major League Baseball, right? Their highest paid players tend to be paid a little bit more, right? So if you look at the maximum salary, it's about $10 million higher, but really the average, right, is about the same, right? 3.6 to 4. It's a little bit of a difference there, but it's in the same ballpark, no pun intended, I guess. But if you look at the annual salaries in Major League Baseball, this is, quite a bit steeper of a slope than in the NFL. Now, if we look at attendance numbers and viewership numbers, this is somewhat surprising because we think that, we see an overall demand for Major League Baseball kind of declining. But, they must be doing something in which, we also have differences in these leagues in terms of, player minimums, player maximums. So a lot of that's going to kind of play a role in the salary data as well. So it's not definitive just because wages are increasing, that demand for the sport is increasing as well, right? And I think I got NBA in here maybe. So NBA, NHL, I didn't have any graphs, but we kind of look back. The maximum salary in NBA is pretty high, and the average is almost twice that of the other leagues, right? Or is twice that of the other leagues, right? So we see that the average salary in NBA is relatively high, and that's probably being driven mostly by that marginal wins coming from each individual labor or each individual player. NHL, a little bit lower than the other leagues. Okay. So this is kind of a quick snapshot thinking about differences that exist. So I drew in the supply curve earlier on that graph that I showed you. And I think we talked about this before, but now I'm wondering if I'm thinking about even in the fall. So we've got our labor supply curve, right? So typically we think that as wages increase, we're also going to see the amount of labor being supplied increase as well, right? I pay you more, you're going to put in more hours, right? But we said with labor supply, what could happen? I keep increasing the wage. At some point, I end up being okay with the amount of money I have, and so I start working less, right? And so, you know, we can kind of think about what's really going on here is, and I don't know if you went over this in your 201 courses, but an income and substitution effect, right? So the idea with substitution is I'm substituting a labor hour with a leisure hour, right? Or a time where I'm not working, if you want to think about it that way. So as I increase the wage, if I want to take a leisure hour, what's the cost of taking that leisure hour? Whatever I'm giving up, right? So I can think about it as I have this trade-off, this substitution between labor and leisure. And as I increase the wage, it just becomes more costly not to work, right? So that's generally how we think about it. But there's also this income effect, which is as I get a larger stock of wealth, right? I now, you know, what's the, if we think about what's the additional benefit of going from making, oh, I don't know, let's say 30 to 40,000, right? Well, if you're down making that much money, I mean, a $10,000 jump is substantial, right? And what if you looked at someone making $1 million or $1,010,000? What's the difference in what's the difference in my lifestyle? What's the difference in what I can afford? Very, very little, right? And so as we see income values increase, additional increases in income become less valuable to the individual. And so this is the idea of the income effect. And eventually, if the income effect overtakes that substitution effect, we can kind of see this, backward bending supply curve. So to investigate this a little bit, let's think about maybe some weird implications that we could get here. So we've got something that looks like this. We've got I'm going to start out with a demand curve down here. And let's say my labor supply curve is increasing, but eventually I hit a wage where if you just keep paying me more money past that point, I'm just going to keep working less and less. Right? And so we started out, so this is my kind of labor supply curve, and here's our initial equilibrium wage. Right? And maybe, I don't know if I gave myself enough room here. Right? And it's my equilibrium quantity of labor supply. So you can kind of see, like, often it's that if we think about normal jobs, like maybe the, I don't know, the stadium workers, it's likely that demand for their labor is ever going to get high enough to come anywhere close to this backward bending portion of supply. Right? But potentially, you know, maybe this is like the labor market for my stadium workers, but you know, what if I had a demand curve that was up here? So maybe this is more for my demand curve for my players, and let's just assume supply would be the same. Well, you can kind of see there, well,
Are we willing to work more?
yeah, so they're gonna be willing to supply a higher amount of labor, and the equilibrium wage is going to be significantly higher. Now, what happens if demand for that player goes up even more, right? So maybe I get something like this. Notice at some point, yeah, the equilibrium wage will continue to increase, but at some point, actually here, I'm just going to draw an arrow because I didn't leave myself enough room. Call this Q2. For some of these players, potentially increases in demand for their labor might drive the wage up to a point where they actually start putting in less, I don't know, thinking about quantity of labor, usually thinking about it as like hours or the number of players, but here it really could just be the quality of hours, right? We could measure it a little bit differently as well.
So like effort?
Yeah, if you want to think about it as effort, or really it would be, we probably would want to quantify it more like times effort or something like that, or, you know what I mean, like kind of the fact that they're putting in more hours, but also that somehow measuring the intensity of those hours. You know? So potentially we could see something like that happen. Kind of the example, you might think about it. It's kind of hard. It's a little bit abstract when we're thinking about the quantity of labor here. But what if I think about someone like a fighter, right? And so instead of the quantity of labor is a little bit easier to measure there because we have like the number of fights, right? So what you typically see is that if we looked at like MMA or UFC fighters, when they are starting out, have relatively low wages, they'll fight several times a year, right? You think about someone like Conor McGregor, after he made hundreds of millions of dollars, I don't even know the last, it's been a while, right? Or he's maybe fighting once a year or something. So he's decreased his labor or he's decreased his labor supply in the sense that he is choosing a lower number of fights because the wage got so high. Right? So we see this play out. It's just for the average worker or probably even the average player, it's likely the demand for their labor is going to be too low to ever really hit that backward bending portion of supply. But we see it at the higher level. Yep.
It should be maybe the quantity decrease, but the quality increase. Like say you're fighting less, you're probably going to be getting much more hurt, so you're going to be fighting more equal.
Yeah, maybe number of fights isn't a perfect measure, right? Because the amount of time I'm putting in to prepare for the fight, maybe there's some quality differences in that time as well. And so I might want a better measure of like number of fights times effort put into each fight or something like that. Yeah, you're right. Like I said, in some of these models, this quantity of labor will get a little bit abstract to think about because it's, we don't really want to think about as when we're looking at an individual's supply curve, it's not the number of workers, right? It's the individual supply curve. So it has to be some measure of labor hours, which is typically how we think about it when it comes to like an average job where you're getting a wage rate or paid by the hour. But here, we probably need a slightly different measure instead of just the hours, like hours times effort or the quality of hours put in or something like that, which is hard, right? It makes it harder when we're looking at the data to get a real good measure of the actual quantity of labor being put in. Any other questions or comments there? Okay. All right, so we've got our labor supply curve. We kind of think about usually that substitution effect will dominate, but if the income effect does, we can get that backward bending supply curve. I think I kind of already went into this. I basically drew this for you, but you can kind of think about it as what if we saw a significant shift in supply? So using Conor McGregor as another example. So let's just assume for a second that they never hit the backward bending portion of the supply curve, right? What if it's something like this? So we'll set up our supply curve for labor. Oh, let's think about it this way. So here's our supply curve for labor. Here's our demand curve. We'll identify the equilibrium. Here, okay. Got our labor market. What's something that the supply of labor is reflecting to us? So we said earlier, demand kind of reflects marginal benefit. And then we said that represents for the team the value of each additional win the player brings in. What does the supply curve usually reflect to us? Yeah, so yep, marginal costs, right? So it's the marginal cost not to the team, right? It's the marginal cost of supplying that labor, right, for the player. So if it's more costly to the player to supply that labor, we would see kind of shifts in that supply curve. Okay? So let's think about someone like Conor McGregor, who's starting out, right? Really the cost of labor supply is what I'm giving up, right? So it's my leisure hours. So initially, if I don't have a lot of income, my leisure hours are not really that valuable. I can't go do anything, right? But think about someone who makes hundreds of millions of dollars. What's happened to the cost to taking kind of giving up an hour of leisure? Well, Conor McGregor could do a hell of a lot, right, with 1 hour of leisure. Like he's got enough money where there's more things available, and so the cost of putting in labor hours starts to become higher. So at every point, you can kind of think about the cost to supplying that amount of labor is now going to be higher than it was before, which is really just reflecting the fact that I shouldn't do squared here. The marginal cost to supplying that labor has increased. So if we start to get these players who build up a pretty good mass of income or wealth, in the future, we could see that they will be less willing to supply their labor. And so, the new equilibrium would be at a higher wage, but a much lower quantity of labor supply. And then if a team wanted to get the same amount of labor supply from them, so let's assume instead that, the equilibrium moves. Well, the team doesn't like this because even if this isn't the number of hours, if this is still just the quality of hours, they would like the quality of hours to remain the same. The team would, right? And so what would they have to do in order to ensure that? They'd have to pay them more. How much would they have to pay them? Well, if they want this quantity on the new supply curve, in order for that player to put in that many labor hours or quality of labor hours, you couldn't just get away with paying them that equilibrium wage, right? You'd have to pay them something even higher, right? Now, would you want to do that? Well, I mean, the cost is significantly greater than the benefit of having the players, so that wouldn't make sense. But if the team wanted to get that same number of labor hours or quality of labor hours, they'd have to pay a significantly higher wage. I'm not saying they would do this. I'm saying this is what they would have to pay if they wanted to. Oh, my hands are in the way, sorry. Any questions? I know I've got a couple of different things kind of going on here. Okay with that idea? So we might see shifts in this labor supply over the course of time, which might, alter our equilibrium wages as well as the amount of labor supply. Okay. So I think I actually kind of jumped the gun here on this one. But usually we think about what the demand curve for labor is coming from is the price of the product we can sell, which is really essentially the marginal revenue from that product, which is the same as the marginal revenue per win. And then the marginal productivity of working, right? So how many units can they produce times how much each one of those units I can sell it for. However, I kind of already mentioned, if I can get this to stop moving, there we go. I already mentioned earlier that when we're thinking about this in the context of what we're doing, we're going to call this the value of the marginal wins that are coming from labor, right? Our product is wins, which we can break down the marginal wins that are coming from labor multiplied by the marginal revenue per win. So we want to have this equation in our minds a lot when we're talking about the labor market. Any questions before we keep moving? Yeah.
So what is VNWL?
Yeah, so I'm shorthanding what I'm saying here. So this would be the value of the marginal wins, I guess, from labor. I guess the from doesn't get any love, all right? Value of the marginal wins from labor. They're coming from labor. Any other questions before we keep moving? This is pretty easy if you guys have had labor econ. Maybe this is a little bit redundant, but so that's kind of where we're at. So let's think about some interesting things. And I don't know, maybe if you actually be interested, is anyone in labor econ right now? Or was it last semester, right? Did you guys do, did you have, yeah, DeSica? Okay, let me know if he did this after we get done with the example. But this is an interesting thought experiment, or at least something interesting to think about. So let's say we've got, so I'm going to draw my labor market down here. You guys can see it. There we go. Okay. So I've got this demand curve for labor, one, and my supply curve. And so there is some equilibrium wage and equilibrium quantity of labor. If we think about instead the product market, right? So here we've got kind of the, actually, I'll just show you a portion. I think maybe it's even easier to, oh, I don't want to show you this. let's think about. Just think about the ticket market for a second. All right. So we've got the price on our y-axis and the quantity of tickets on our x-axis. So let's think about if I've got my demand curve here, and let's make it a little bit easier. Well, let's do something like this. So here's my capacity. So we're currently selling out, right? And if I am acting in a perfectly competitive market, I don't make decisions off of my twice as steep marginal revenue curve. It's just wherever that demand curve hits supply. So I would have kind of my ticket prices being relatively low. Now, the reason why I'm just looking at the ticket market here is it's just one component, but I think it's easier to think about. If I've got my demand curve for labor, which we had is this, part of the additional revenue per win is going to be however much money I can make in that ticket market, right? And so I look at this price and, maybe I multiply that by the quantity of tickets and I figure out that there's some additional revenue there, or sorry, additional revenue. I find out that, whatever that value is, the amount of revenue that's coming, ticket revenue coming from each additional win, right? So that, is going to factor into my demand curve for labor because ticket revenue is part of the additional revenue per win. Okay. Well, then if I see a shift, right, let's say I see an increase. I'll do, let's think about if we have a monopoly, right? So they then start making this decision based off of a twice as steep marginal revenue curve. Sorry, we can kind of think about they're going to sell a lower number of tickets, but at a higher price. And because it's the profit maximizing point, we know that the profits that are going to be created from the ticket market here have to be greater than what they were before, right? If I'm acting in monopoly power, that means that I'm increasing profits from that perfectly competitive point, okay? So I know that, I probably should have done this in red, but I know that that's going to then, I'm generating additional profits or generating additional revenue from my ticket market, that's going to influence the additional revenue per win. So that's going to increase my demand curve. Right? So if we looked at a market that was monopolized relative to perfectly competitive, we actually expect the monopoly will be willing to pay higher wages. And the reason why is because the monopoly is able to charge higher prices, right? So my product is now worth more, right? The revenue that's coming from each additional win is now a higher amount of revenue, right? So if we actually look at a monopolized market relative to a perfectly competitive market, we would expect the monopoly to have a higher demand for labor because it's able to charge a higher price for whatever product it's selling. In this case, it's kind of weird because it's several markets, right? Several revenue markets. But as long as like one of those revenue markets is monopolized, we potentially would see that, well, now the players are worth more to the team because that marginal revenue per win is higher, and we'd end up with higher equilibrium wages. It kind of sucks because we don't really ever have a good way to measure this. It would be great if we had one sport that had competing leagues. I wonder if you might be able to do something with, I was going to say like European soccer, but they're so like, things are so closely tied to the countries they're in that, yeah, I don't know how you would really get true competition there. But if we somehow had a league where we had a sport with two competing leagues, maybe then we could kind of see what would happen to wages as a result. Right? But almost every other sport we look at, we know they have monopoly power, but that actually in a weird way, it can be a good thing for players, right? It can actually drive their wages up. Any questions before we keep moving there? Did you guys discuss anything like that in labor? The differences between market structure and the wages?
A little bit.
Yeah.
Then we talked about
No, it's all right. No, but it is an interesting thing, and because every market we see in sports is predominantly monopolized, we think this is probably going on with the wages. What if we had differences in market size. So I don't know if I have a slide for this, but if not, I'm ad-libbing. So let's go wages up here. We then think about, we've got some demand curve for labor, some supply curve for labor. And we'll call this small market teams. Okay? So QS and WS, right? We've got our equilibrium wage and quantity for small market teams. Now, I'm going to write this out like probably a million times, but I think it's good to have the visual in front of you when we're talking about it, right? So here is the equation for my demand curve. If I know that large markets are generating a higher additional amount of revenue per win, right? We can think about when we're drawing that win market. Remember, the large market always had a demand and marginal revenue curve that was shifted up. So we know that for large market teams, the marginal revenue per win is going to be higher, right? And so that's going to drive up my demand curve for large market teams. And if the supply of labor is the same, right? They don't care if they're in a small or large market team. We'll assume that for a second. Then potentially, we would think in large markets, we would expect to see higher wages, right? And if we didn't have things like roster requirements, like you had to have a certain number of players, we would expect that they would have a few more players as well. Or here, maybe they're getting some higher quality labor hours, even from the same number of players. So kind of the difference in small and large market there, we can already see, you know, part of the thing that's driving up kind of the quality of large market teams is they're able to, you know, they're paying players a higher wage, right? We would expect that from the labor market. Now, you could make an argument here that let's assume the supply for large markets, you think the supply might be a little bit higher or a little bit lower. So if we think about what supply represents, it's the marginal cost, right? So supplying the same labor hour in, I don't know, Jacksonville, Mississippi, or Jackson, Mississippi, what might be true about the cost of that labor hour if I was comparing that to maybe a labor hour given up in LA?
Probably less than be given up.
Yeah, you think about in larger markets where there's more kind of things to do, or there's just more opportunities, potentially the cost to supplying labor is a little bit higher, right? So maybe, right, I get some differences in my supply curve there, kind of having a higher marginal cost giving up that additional labor hour. You know, then my equilibrium is going to be here. So notice if there are supply differences, maybe I get quantities of labor that are kind of more similar between large and small markets, but those supply differences are also going to force wages to be a little bit higher in those large markets as well. So if we're looking at large versus small market teams, you know, we should expect to see higher wages for sure, right? It's hard to measure the quality of labor hours there, but if we could, you know, we would expect that, you know, maybe they're higher, maybe they're actually lower if that supply curve difference across these cities is significantly high. Any questions on that? All right, so we got a little bit of large, small market discussion there. We talked about perfectly competitive versus monopolies. So I kind of already walked through all of this, right? If we're just pushing the price of the product up, well, here, the price of our product is the marginal revenue per win. So if monopolizing the ticket market or something along those lines would drive up that demand curve, we would expect to see that from monopoly, workers end up getting paid a little bit higher wages. Okay. Oh, so I did do small versus large market. You know, I think I probably could have said this way earlier. All right, we have been identifying these equilibriums. It's going to be where our labor supply hits our labor demand curve, right? And we can think about shifts in that demand curve, right? Either coming from the marginal wins coming from labor, or the marginal revenue per win, right? Those might both have influences on that equilibrium. So we should be able to kind of draw those shifts, identify the new and the old equilibrium, and think about how wages and the quantity of labor has changed as a result of that. And we'll work through some more examples. One thing that we'll actually dive into probably next week, I don't know if we'll get there Thursday, is then start to think about things like discrimination, right? And kind of put that into our model as well. So I've already talked about this a little bit. When we're talking about the number, kind of the quantity of labor, the number of workers or players may not change, right? So if we have things like roster limits, I think that is that what I have in the next slide? Yep. So let's think about, I've got supply curve for labor like this, right? And the quantity of labor. And let's say I do have an equilibrium wage. So maybe this is, we want to think about this as when we're thinking about a labor market. There's a labor market for individual players, especially if there are no substitutes. So when you're looking at high quality players, it may be that the only supply curve, the only producer that we have, or the only person supplying labor of that quality, is there might only be one player. So for instance, I don't know, I've been trying to watch some more NBA basketball, but I don't know if there's a consensus, but let's just say go back 5 years ago or however long, and say that, you know, LeBron James is by far was the best player in the league, right? Or go back and Michael Jordan, right? So if you want that quality of labor, there's only one person that can supply it, right? There's no substitutes. So it's hard when we're thinking about the labor market to think about things like equilibrium wages, because we know that Michael Jordan shouldn't be getting paid the same as Horace Grant, right? Or whoever, choose your other player, right? However, if we want to think about maybe something like at the lower end, well, there's a lot of players who are very close substitutes, right? If I'm thinking about my bench players, I don't care if I've got, you know, I don't care who's sitting on my bench, right? I don't care if, as long as they're able to supply the same quality of labor. So it's likely at the bottom end of like the ability distribution in these leagues, you've got players who are really in the same labor market. They can supply the same labor as other available players as well. Now, there's no one who can supply the same amount or quality of labor as maybe Michael Jordan, but they can supply the same amount of quality of labor as other people that are on the bench. So that's what we'll be thinking about here. Let's just kind of think about this as like maybe the equilibrium wage for bench players or like backup players. So there are supply curve and our demand curve for labor, and maybe, you know, this is where our equilibrium is. So when we're thinking about these bench players, really what they're doing is they're filling out the rest of my roster. So if I have kind of a full, you know, I'm trying to hit that full roster. I don't know what it is. I don't remember what it is in the NBA, but choose a number. We'll say, I don't know, 15. We'll go with that, right? Then potentially this quantity of labor is too high. So maybe it's good. I like to just have a lot of backups, right? Maybe it's for practice purposes or whatever it is. And so I don't know, maybe this is something like 25 is the equilibrium. But the league says I can only carry a roster of 15, right? And actually we could even think about this might just be the remaining available spots on the team after I get rid of like my starters and people who actually play. So maybe the league sets a roster limit that's a little bit lower than whatever the equilibrium quantity would be. So how does this play out? Well, at that quantity of labor, right, for those players, we know that the players would work for as low as this wage, and that teams would pay as high of wage as wherever they're at on their demand curve. Right? So this is where, you know, it's likely that these teams have a little bit more power, right, than the players do in these scenarios. And we could see a wage anywhere in this range, but it's more likely that we see teams have the ability, because they have more power in that labor market over these bench players, to actually pay them all the way down to exactly whatever wage they were willing to supply that labor for. And like we haven't built in any like monopsony here. We haven't built in any union power here. This would just be if we had none of that, right? Roster limits, potentially we can kind of see lower wages for those bench or those reserve players. And the league recognizes this. So because a lot of them have roster limits and they realize this potentially could be occurring for those players on the lower end, what do they typically have some of these leagues started doing? You can't get away with paying someone $1, right? They have roster, they have league minimums.
Okay.
So like you can't like they just say kind of like a minimum wage. So like you can't just pay players like nothing, right? And so maybe one way to combat this is to impose kind of some league minimums. But you don't have to. It's just something that some of these leagues have done. Does someone have a question? Maybe I saw a hand and I forget what it was.
Well, I was gonna ask, so that's dead weight loss right there.
Yeah, you could think about it as if the league did this, what they're really doing is creating some dead weight loss in this market, right? And if they are able to get away with paying this lower wage, why might that still be a good thing? Well, what's producer surplus here? What's consumer surplus here? The area under the demand, all the way down to the price they're paying, which is now the wage. So, they've gained all of this surplus here, even though, just lost a little bit here. So it'd still be good for the league and the teams to do something like a roster limit because they can increase their surplus, even though they have created some dead weight loss for society or right the market. Any questions on this before we keep moving? Okay, so kind of went through that. So in practice, right, do we see like at the point, which was the best one that I had to make this point? Probably like the first 900. So think about here, whatever our equilibrium wage is, it should be, we're on our demand curve at that point. So the wage of the players getting paid should be exactly equal to the value that they have of the team or the value of the marginal wins coming from that labor. Right? So do we see this play out in practice? Right? So there is this really interesting paper that, and we haven't even thrown in monopsony power. I mean, we've talked about it prior to spring break, but we haven't even put this into some of these models. But we can think about, so we can kind of even throw that in there, and we'd have even more reason to believe that maybe wages don't end up being exactly equal to the value of that player to the team. So there's this paper written in 2006, and this person tried to estimate what the value of the marginal product of labor was for every player in the NBA. So they knew that it comes from the additional revenue per win and also the change in wins coming from that player, right? The marginal number of wins that player is bringing in. So what they did was they ran a regression where they looked at all these statistics, right, for these players. So points, rebound, and I think I shorthanded it here. They might have had some additional ones in there as well. But they used all of these statistics to predict the change in the number of wins that a team would see if they had that player who had these specific statistics on it, right? So they're using all of NBA player data to kind of come up with coefficients on each one of these variables, right? So they then could determine how many additional wins every player brought in. And then they used some revenue data for the teams and kind of looked at like what the average revenue per win was. It's not a perfect measure, but it was pretty close as what they could get. And once they had those two things, they could determine what the value of the marginal product of labor from that player was. And then they could compare that to what their actual salary was. So we get an idea about, okay, here is the estimate for what this player should be worth to the team. Here's their actual wage. Do they match up? Okay. So LeBron James from this paper, they kind of chose a couple players to pull out individually because they had to do this for every single player, right? They ran this regression. So think about the most simple form of that regression. So let's say we've got the number of wins, and then we've got an intercept, and I've got just points. Obviously, all the other statistics will be more helpful in predicting the number of additional wins, but we'll just do points to make the point. So let's say, you know, I don't know, I come up with a coefficient for on the number of points being 1,000. I don't know, there's some intercept value. What I could then go through is I could go through every single player and say, okay, how many wins did that player bring into that team? Right, what's the number of additional wins that player brought in? Well, if I added this player who scores 30 points, then the number of additional wins would be 5 plus 1,000 times 30 points. Right? And maybe this is like points per game. I think that's what I was thinking about throwing this number in there. I think they actually did total, but same idea. And then, you know, for another player, I could say, okay, how many additional wins did they bring in? Kind of predict the number of additional wins that player brought in. But maybe this player only scores 10 points on average a game, right? So I would go through and come up with this prediction for the number of additional wins that player brought in for every single player. And not only just for points, but all these other statistics, all these other variables on that right-hand side as well, using all those other coefficients and all those other values for the X variables that were coming from that individual player. Okay. So that's what they were doing. And in that process, they found LeBron James actually adds about 17.3 wins to his team. Man, it's not like that, but that's pretty significant if it's coming just from one player. And when they backed out how much that should be worth to the team, it was about 29 million. His actual salary in 2006 was only 17.5. Pretty big discrepancy there, right? I think the other one that was really interesting, may not expect, is Tyson Chandler had a very high number of additional wins, being worth 22, only paid 13.6, right? So, I mean, both of these players, you can see they're being paid almost $10 million lower than what their value to their team should be, right? So we've got some inconsistencies. The theory predicts that they should be getting paid exactly, but we haven't worked in a lot of things that we've talked about that could skew this, which is things like monopsony power, right? We know that if teams have monopsony power, it's likely that they can get away with paying players lower wages, right? So that's probably what's driving a lot of this. So why doesn't it hold? Yeah, the paper doesn't say that it's I mean, they don't go into monopsony power. These are things, and they actually say that they did some real goofy stuff where they like, this is weird. So the good way to do this is run a regression, actual data, obtain your coefficients. Right? But what you can do is run this huge matrix of possible coefficients and figure out which one of these combinations of coefficients comes up with the predictions that best match the actual values, right? So what combination of coefficients would predict exactly what not predict what the player is worth, but predict what the team's actually paying. And then you can look at those coefficients and say, okay, so this is what teams are behaving as. How are these wrong, right? How are these coefficients, this like that we look through this entire matrix to find, how do they not match up with what the actual coefficient should be if you run this linear regression? And then from that, they kind of find that really the reason why is teams focus way too much on points. So for instance, like Tyson Chandler, if you look at his statistics, right? Rebounds were a significant, right? You know, one of his, I guess, strong suits. And so if teams don't value rebounds as much as they do points, then he would be an example of a player who's going to end up getting paid less than they should. Do you have any other questions?
Oh, no, I was
Okay.
talking about that. I was say Jim my dream.
Yeah, I mean, you could choose choose your player. You know, there's a handful of them out there that you could look at and you say, well, look, their points aren't very high, but these other measurables that have influence on the game, you could do this in any sport, right? I'm sure if you did it in the NFL, you could find some real serious pay discrepancies, especially because there's such a variation across positions as well, right? There's not as much variation across positions in the NBA as there is in the NFL. All right, where are we at? Okay, so I might skip around a little bit. Let me see. We can do the skill acquisition stuff. So if we think about teams, once they obtain a player, right, they're benefited by, like they're already paying that wage, right? So they will then benefit if they can increase that player's quality, right? This is the idea when teams sign rookies. If the rookie ends up being good, this is a really good thing for the team because they might lock them into a 4 or 5 year deal, paying them a pretty low amount of money. And if that player continually gets better, they're now like underpaying them, right? Because their quality has gone up, but they keep paying them whatever that original contract was. So teams want to invest into their players to improve their quality, right? So we can think about this investment, it's going to come at a cost, right? Whether or not that's a cost of coaching, or that's not a cost in improving facilities, there's going to be some cost to that, right? However, once they pay that cost and once they invest in this player, they expect to see an increase in their productivity. Marginal productivity increases. Here, our product is wins. So we could think about the marginal wins coming from that labor should increase. Right? So what might be one problem if they saw the marginal wins coming from that labor increase after they made this investment? What's that going to do to my demand curve? So if it's increasing the productivity of the player or the marginal wins that are coming from that player's labor, what's that going to do to my demand curve? It's going to increase it as well. So if it increases my demand curve, if I had to sign a new deal, that player would be getting a higher wage, right? So I've invested all this money to try to get this player to be better, but then I have to then not only pay the cost to get them better, I then have to pay them more once they are better, right? So that's not a good deal. And so this is why you would see investment, and you might see longer contracts from teams, because once I have a longer contract, I know, well, I don't have to pay this higher wage. We've already signed the deal, but if I can improve that player's quality, but I keep paying them the same amount, right? I'm paying them well under what their actual value is to me, right? So if I can make this huge investment, I'm now essentially underpaying that player. I'm getting more out of that player than what I'm paying, right? So how much would I be willing to pay up to? Well, really here I could think about it as whatever that new value of the marginal productivity of labor would be, the difference between that and whatever the wage that I'm currently paying them, that's the amount that I'll benefit from investing into this player. So as long as that additional benefit is greater than that additional cost that I had to pay, then it makes sense for me to invest in this player, right? If the sign flips and it gets to become too costly, that even if I make this investment and I'm now underpaying the player, but the amount that I'm underpaying them, is much less than what the actual cost was, well, then I won't make that investment, right? So, it's probably why you don't see you see a lot of players investing in themselves. You don't necessarily see teams paying these huge amounts, or I don't know, giving every single player a personal trainer, or every single player, right? Maybe for the top end, but not every single player, right? Because for the lower end players, it's going to be a pretty big cost, and you may not really improve the quality of that player very much. Right? So that's the idea behind kind of what they're thinking about in terms of what the benefit is to investing into this player. So we might see that the wages, if they had to negotiate every year, they would have to pay higher wages. So how do we avoid that? Sign longer contracts. So another issue with this, if we think about if they were signing a new deal every single year, what might also be the problem? Well, if this player is of higher quality, there might be more teams that are looking to kind of sign that player. If I lose that player, I paid this huge cost to make them better, and now they're on some other team, right? And so, it doesn't make a whole lot of sense to kind of have this skill acquisition cost if the player might potentially just not be on my team the following year. Okay. So we don't see teams really investing a lot into general skills, because if I have relatively short contracts, or I think about the costs are too high, then it never makes sense to kind of do this general skill acquisition. Right? Now, what we're assuming here, at least the way I've discussed it, is that once they make this investment in the player, well, if that player leaves, they're going to be the increase in quality, they're going to take with them, right? If they're going to be better on my team, they're going to be better on other teams as well. A little bit different Oh, sorry, I had an example here. What was I thinking about? What did I mention? Oh, yeah, so they don't make the investment. So a lot of times it's players that'll make the investment themselves. And kind of think about maybe where we do see them do this is something like the minor leagues. And the reason why is because it's relatively low cost, right? They actually, some of them, they can actually generate a profit out of these minor league teams. And it also allows them to kind of build the skills of those players, right? Who are under contract with them. So what if, instead of like a general skill, you could somehow invest in a specific skill or a team specific skill for this player, right? So if we think about what that would do, so maybe something like coach this player into playing a certain scheme or offensive or defensive scheme. So I think that, I always hear commentators like in football talk about this, where it's like, I don't know the X's and O's of football at all, but they talk about 3-4s, 4-3. So maybe you get players who are coached to be really good at a specific scheme, right? So it's a team specific. That's the scheme that team is using. And so how might that look a little bit different? Well, we think about this labor market for the player. Starting out, we've got some original equilibrium point. Looks like I need to go get some new markers after this class too. So maybe we start out right here. So if I could increase that player's skill, we said, well, what's going to happen? If they stay on my team, right, and I get to keep paying them this lower wage, right, essentially, right, I'm underpaying them, right? Now, if this was a general skill, we said, well, yeah, once they have that increase in demand, though, like the equilibrium wage on the market for that player is going to be higher. And so they're just potentially going to leave and go to another team. But what if this is the value of that player, right? We only get this demand curve shift from the teams where their value increase. So we think about if we call kind of team A, the team that the player is currently on, right? So we've seen an increase in the marginal wins coming from that player or coming from labor on team A because they gave them a very team specific kind of quality or kind of, skill boost, right? But for every other team, right, we'll kind of call these team B, like maybe we think, there's just one other team in the league just to simplify it, but it wouldn't matter if there was just several other teams. Well, even if we assume that the marginal revenue per win is the same, right? So like no differences in market size, like these teams are generating the same additional revenue per win. Because that is a team specific skill to learn that offensive scheme, if that player went to team B, their value goes back down to what it was before that investment in their skill was made. So if I do general skill investment, well, then I'm either going to have to pay a higher wage or the player may just potentially leave and I paid all this money and got nothing. But if I can make it team specific, well, now I know that this player, if they go to any other team, they'll get a much lower wage than what I would be willing to pay them, right? And that there is no, they don't have any additional value to any other team but me, right? Now, obviously, it gets more complicated than that because we could think about, maybe there's only, maybe I'm not the only team, maybe like 25 teams that this skill wouldn't work for, but maybe 5 of them it would. Well, I've at least decreased my competition for hiring this player, right? So even if that is the case, we would see the same sort of thing play out, probably just to a lesser degree than if we had this really dichotomized, like all or nothing kind of example. But this is the general idea about why team specific skills we see teams invest in. Well, if it's just general skills that really would improve the quality of that player on any team, well, we don't see teams investing as much into that.
We see teams making their schemes similar to other teams just to increase their player value.
Yeah, that's actually a really good point, right? So if my current scheme, if my current scheme is a minority scheme in the sense of like the majority of the league is running another scheme, right? Or doing, something else. Then the value of every player on those other teams, to me, is really low because they can't run my scheme. But if I adopt the majority scheme of the league, well, now all those other players their value automatically goes up to me from changing. Probably whether or not that's optimal, probably, like I said, I talk about it in terms of majority, it probably depends on like how much of a majority scheme it is versus maybe the growth I see from players to my specific scheme. So it would get it would get pretty complicated pretty quick. But the idea there, if there was a scheme where the majority of players had that skill, but didn't have the acquired skill for my scheme, it may make sense for me to switch over to what the majority of the league is doing. Yeah. Any other questions? It was good. It's always like some of these things I'm like just trying to give you some of the basics. Like we could take these thoughts out for a long time. So I always appreciate and enjoy comments like that. So we kind of already walked through this. If they threaten to leave, right? Well, it's kind of an empty threat because the team knows that you're not going to be as valuable as any other team other than ours, right? If we've given you this team specific skill. Yeah. I think we'll pick up in this next class. So we've monopsony reserve clauses. We'll go into some PE stuff. We'll revisit unions, talk about free agency. I'm hoping we'll get here because this is a pretty relevant topic. Too bad it wasn't a little bit sooner in the semester. What do I want to go down here and show you though? I'll also, so just to mention a couple things. So I'll put an online quiz up after class today. That'll be due before we start class Thursday. Just a couple easy questions about the labor market to kind of make sure everyone's kind of following on what we're doing. The second thing is, I'll put up the paper that we'll kind of discuss on Thursday. It'll actually be looking at sports participation and academic performance. So it's kind of an interesting paper. It's a little bit different than some of the stuff we've looked at, but it's got some good linear regression results. And then I had this. So I thought this is kind of interesting. We could really take this out of the way. So one thing that I'm going to do when I get back to my office as well is I'm going to put up an announcement that has a link to ESPN, and we're going to do like a bracket challenge for this class. If anybody can beat my bracket, I'll give you all 5 points of extra credit on the online quizzes. If you all do one, there is almost a 100% chance one of you will beat me. I have no, it's just the more of you that do it, you increase your odds, right? So you can do that. Click on that link. I'll just do it through ESPN, so I don't have to go through and hand score all of them. It'll kind of do all of that for us, and I'll probably make known who wins at the end as well. So you get a little bit of a social kind of benefit there of knowing that you're the best, right? So I'll get that announcement up there on Canvas so you can kind of have that link. The password, I think I'll put it in there, but it's just Lantis 330, right? Of course, name. So it's kind of interesting. We start thinking about the NCAA bracket, right? We've got 64 teams, right? All playing to the championship game, all with different seedings. You get a higher seed, you play a lower seed. So how many possible combinations of victories could we do, right? Well, for every single game, I have 2 choices, right? I could choose team A, team B. Right? So if we think about like the college playoff, how many different ways could I do that? Right? Well, I could do team A wins, they play, and I choose this one. Team B wins, they play this one. So we've got 3 games that are being played, right? 2 semifinal games and then the final. How many different ways could I choose that? If we actually kind of write them all out, it's a small number of games, we can prove to ourselves there's 8 different combinations. And really what that comes from is if I have 2 choices for every game and there's 3 games, the set of combinations would be 2 to the 3rd. So if I think about a 64 team tournament, if I've got 2 choices, 63 different games are being played, or sorry, 64, right? No, it is 63. It's 2 to the 63rd power, which is this ungodly large number. Like that's the number of possible combinations. right? And so your chances will be 1 out of, I don't even know what that is, right? This is so incredibly low. But then you look at me and you're like, well, yeah, but every game isn't a 50-50 chance of a team winning. Like, you can make some educated guesses, so to speak here. So if you use past data where like you see, there's only been what, 1 upset ever. So you can start to build in the probability based off historical data that different teams win, right? And then if you make decisions based off of that, someone kind of worked all the math out, and there's still the probability you get a perfect bracket is what, 1 over 128 billion, right? So it's still, even if you have like all this historical data, you make the most, informed decisions possible, you still have a very low chance of getting a perfect bracket, which is why they offer like all these sites and things, absurd prizes if somebody does because they look at this and they're like, yeah, it's like never going to happen, right? I mean, it's very unlikely it's going to happen. So it's kind of interesting. I thought that was, I could have come up with this on my own. I actually did, but I didn't want to take the time here. So I found someone that had done this, and then I thought that was kind of an interesting statistic. So online quiz before we start class Thursday. You can fill out the bracket, and I think I have it set so as long as you do it before the games start Thursday, right? What doesn't, the play-in games aren't one of the ones you can choose, then it should be okay. I will probably have the next homework posted after class Thursday. So we haven't really went through a lot of new material, obviously, but I'm going to get it out there early so you can start working on it as we cover the material. Okay. All right, it's good to see you guys back. Enjoy this nice weather, and I will see you guys Thursday.